This is for Year 12 Methods. It comes out of the Technology Refresher Masterclass. It's question number 3. State the domain and range of these. Okay, I'd like to graph them to get an indication. Looking at this function f of x, because I have an x squared in the denominator, I'm thinking that x can't equal 0, but x can be anything else because anything can be squared. And if that was negative, it makes no difference. So I'm thinking that the domain is going to be all numbers except for 0. So let's have a little look. I'm coming over here. So I need a fraction, and I need x squared, and then I need e, and I'll put a fraction in there, and I've got 1 at the top, and underneath I've got an x squared, and all of that's over 2. Press XE just to make sure it cleans up exactly as I would expect. It is. Open up a graphing window in the second half, edit, clear all, OK, and drag and drop, and I get my graph. And as I thought, I'm having some asymptotic behavior with x approaching 0. So x can't equal 0, but it can equal anything else. Beautiful. I'd like to use my calculator to go analysis, gsolve fmin, and fmin will give me the lowest y value, and there it is there when x equals -1, and it's some sort of value that is a non-recurring decimal. So what I'll do is I know that it's at -1, and if I come back up here, bring up my keyboard, math3, given x equals, and I'll put in -1, that will give me the exact value of what that is, which is, looks like e divided by 2. Turn it into decimal, that's the same answer as that. Therefore, turn that back into standard, it's e over 2. So my range, coming back over here, should be e over 2 to infinity, square bracket on the e over 2, because it actually does equal it. So just double check that again. Okay, here is my lowest value, which is e over 2, and it should be the same as on the other side. So analysis, gsolve, ycalc when x equals 1. Okay, and that is the same value. Okay, so that's good. That's my domain and range for that particular one. For this second one, I might go edit, clear all, okay. I've got, bring up my keyboard, fraction 3x plus 4 over x plus 2. Now, this actually is a hyperbola. I can confirm that it's a hyperbola if I do transformation, fraction to fraction. So, sorry, I'll do that again. Transformation, fraction, proper fraction. And there it is there. It's got an asymptote at y equals 3, and an asymptote at x equals -2, which is why -2 has been restricted out of the domain. And it's a negative hyperbola. So turning into a proper fraction turns it into the form that I like. Okay, I'll bring up a window. Since my previous one's there, I'll do clear all, okay. If I take this, drag and drop, there is my hyperbola with an asymptote at 3 and an asymptote at -2. I've got a restricted domain, so I'm going to change my window view of the x's from -4 to 4. Okie doke. So, I know my domain has been given to me already. So my domain is -4 to 4, except -2. The range, well, it's going to go down to -infinity and up to +infinity. It's going to approach this value here. So if I take this and I make x equal 4, that will give me that value. And if I take that again and make x equal negative 4, that gives me that value. So if I bring up my window again, I know that I go from negative infinity all the way up to 8/3, and then I go from 4 up to infinity. So I've got negative infinity up to 8/3, union 4 to infinity. I never get to infinity. This here is when x equals 4 and x doesn't equal 4, so it doesn't equal 8/3, but it does equal negative 4, so it does equal positive 4 up to infinity, and that's my answer.